Let me now present new extensions of partial equilibrium modeling with the introductions of value chain. So let me introduce right now a value chain, and we keep a world market in the model, in this new model. So the idea is to introduce different stages of transformation. Here we are going to introduce only two stages of transformation because we want to start with something very simple. This is a very important topic. What's interesting here is that if there is a policy applied at a stage of transformation, it affects all other stages, not only this one but also other stages. For example, if you've got three stages of transformation, 1, 2, and 3, and if you apply, for example, a production tax at the second stage of transformation, it affects, of course, the demand which is addressed to the upstream stage, that is to say stage 1, and because, of course, the activity at stage 2 is modified. But it also affects the price at stage 2, and so it affects the cost of production at stage 3, which is the downstream stage. So it's why this is so interesting to model a value chain. And this is a major stake for policymakers today because for many policymakers in plenty of countries, it's a priority, the insertion in global value chain. So what we are doing is that we are modeling value chain under a very simple specification. So what we are going to suppose is that there are only two stages of transformation. First, an upstream stage, which is the cultivation of soy. And soy is used in the livestock sector as a feed for animals, and this is the downstream stage of transformation. And so we have got something very simple with only two stages of transformation. Why? Because I want to start with something very simple, and this model will be complexified during the second curriculum to do something which is much more realistic. Because in fact reality is much more complex. So how to describe reality? In fact, the key sector is the crushing industry. So the crushing industry is using some oil seeds like soy, rapeseeds, sunflower to extract vegetable oils, and the rest of the process is what we call cakes, which is full of protein, which is good for feeding animals. And so cakes are used in the livestock sector. The livestock sector is used by slaughterhouses to make meat, and meat is used by the food industry. And vegetable oils is used in the food industry to be sold to final consumers, or it is used as an input by the biodiesel industry, in particular to make biodiesel for fuel for transportation. So we've got something very complex in the reality. It can be done, but of course it requires some advanced modeling capacities. So how are we going to model this very simple value chain? What I'm going to ask you is to start with the previous model. So it's a model of a world market. And what we are going to do is to apply this model to the soy sector instead of the wheat sector. And what we are going to do is to introduce a second sector with exactly initially with the same structure, and this sector will be the livestock sector. So in fact you will have the letter M for each annotation. So for example, the supply will be XSM in country R, the demand will be XDM in country R, the local price will be PM in country R, and the world price will be PME. You will have also some custom duty and some export tax, and they will be called TM and TMX. So let me present how we model this relationship between the upstream sector and the downstream sector that is characteristic of a value chain. This is done through two relations. First, a relation between demand for soy and supply in the meat sector. So in fact, it is demand in the upstream sector. It depends on the price, local price in this sector, but also it depends on local activity in the livestock sector, because it's the main customer or the only customer for soy. Okay, so it means that we have demand for soy in country R, XDR, which depends on the local price of soy, PR, according to a decreasing relationship, but also on supply in the meat sector, XSMR, according to an increasing relationship. So this is the first relation characterizing this value chain. The second relation is the fact that the supply in the downstream sector, livestock, depends on the price of the livestock. This is the output, so it's the usual relationship, but it also depends on the price of soy, which is the input. So more specifically, we have XSMR, which is the supply of livestock, depends on PMR, which is the local price of livestock in country R, according to an increasing relationship, business as usual. But it also depends on the local price of soy, PR, according to a decreasing relationship. So in fact, this model is inspired from a model by Groningen, the chapter entitled Multi-Market, Multi-Region Partial Equilibrium Modeling, in a collective book edited by Joseph Francois and Reinhardt, entitled Applied Methods for Trade Policy Analysis. This is a very good book that I'm recommending. So what we do here is we have a hypothesis of homogeneous goods in terms of soybeans and bovine meat. So the soybeans and meat produced by 16 countries and regions in the world are exactly the same. We've got data of production and prices from FAO Stat for the 2013, and all data are in tons, US dollar or US dollar per ton. So how are we going to calibrate the model? We have exports. In reality, we have exports and imports in each country or almost each country. So we make the difference between exports and imports. If it is positive, we suppose that the country is only exporting, and if it is negative, we make the assumption that the country only imports. And then we adjust the local consumption on the difference between production and net exports. And we also make the adjustment of production and consumptions in the rest of the world as the difference between production or consumption in the world minus production or consumptions in all other regions. And finally, concerning taxes, import taxes or export taxes, so we have a world price, we have local price, and so we calibrate tax data based on differences in production price. So it means that if we have a local production price which is greater than the world price, we suppose that there is an import tax which is the difference. And if this is the opposite, we have an export tax. So here you've got the list of countries and regions. So the set of countries, which is still called R. So you see that the first column is the GAMS code, while the second one is the text, which is optional. So you've got USA, Brazil, Argentina, China, India, Paraguay, Canada, Uruguay, Bolivia, Ukraine, Russia, South Africa, Indonesia, Italy, Nigeria. And the last region is the set of all other countries, which is called ROW, which is the rest of the world. You notice that you have two African countries, Nigeria and South Africa. So here are the data that you need to feed the model. So you've got T, which is the import duty in the soy sector by country or region, TX, which is the export tax in the soy sector, XD, which is the demand for soy in each country, XS, the supply of soy in each sector, in each country, TM is the import duty in the livestock sector, TMX is the export tax in the livestock sector, XDM is the demand for livestock in each country, and XSM is the supply of meat in each country. You need some elasticities to feed the functional forms. I remind you that we only employ functional forms which are isoelastic. So the first two elasticities are elasticities of the supply of soy and the demand for soy, and it's with respect to the local price of soy. So EXSP is the elasticity of the supply of soy with respect to the price of soy, local price, and EXDP, the elasticity of the demand for soy with respect to the local price of soy. Then we've got two elasticities, the same but for the meat sector, or the livestock sector. So we've got EXSMPM, which is the elasticities of the supply of meat with respect to the price of meat, and EXDMPM, which is the elasticity of the demand for meat with respect to the price of meat, local price of meat. And then finally, you've got the two last columns with the elasticities which are unusual, I would say. So EXDSM is the elasticity of the demand for soy with respect to the supply of meat. And EXSMP is the elasticity of the supply of meat relative to the local price of soy. So you still need some data before running the model. So the world price of soy is $478 per ton. The world price of meat is $1,636.7 per ton. The world supply of soy is 286,093,000 tons, and the world supply of meat is 67,511,376 tons. So as I said earlier, this model is very simple, and it's possible to design more detailed specifications of value chain. So if you want to consult a bibliographic reference, you can see an article that I wrote with Carmen Estrades and David Laborde in 2014 in American Journal of Agricultural Economics, which is the study of differential export taxes along the oilseed value chain. So what is doable is to introduce substitutes at a stage of the value chain. So for example, there can be a substitute to soy at the first stage of the value chain. For example, sunflower, rapeseeds. What is possible also to do is to make a stage producing two goods instead of one. So, for example, the crushing industry can produce vegetable oil and cakes. So this is not what we are going to do right now. What I'm asking you is to design the model and to study the impact of the liberalizations of the soy sector, then of the livestock sector, and then of both sectors. Be careful, because a shock can be very important, so it can be hard to have the shock implemented. So an option is to implement a shock in several stages. So, for example, if you study the total liberalizations of both sectors, and you've got some difficulties to get the shock run, so what you can do is to first liberalize the soy sector, ask for a solve of this first stage, then liberalizations of the livestock sector. And if it is not enough, if it remains difficult, what you can do is, for example, to cut the shock in 2 or 3 or 4 stages. So, for example, if you want to cancel import duties in the soy sector or the livestock sector, you cut the import duties by half, you ask for a solve, and then you cancel completely the import duties in this sector.